Okay, is a moment distribution method. So once again, you can see what is the moment distribution method. Moment distribution method. There is no calculations. Just distribute moment between the joints. That's enough. No need to calculate rotations. No nothing. Just distribute. We have to find out if the ends are fixed end moments. Later, if we allow the rotation, we have to distribute. How can we distribute? Based on the distribution factors and carryover moments. Carryover factor. How it is distributed? Distributed through these are the carryover factors. Distributed through distribution factor. Distribution factor based on stiffness of the members. So what is the stiffness of the members is based on EI, flexural rigidity, divided by L, length, and also whether the far end is hinged or far end is fixed. Okay, far end is hinged or far end is fixed. Okay, whether it's a far end is fixed or far end is hinged. Based on that only, we have to find out the whether it is a how can the distribution factor is distributed. Okay, so now we will see problems. Okay, so one. Okay, we will see the problems. We will see the problems. Different. We already seen one problem yesterday's previous classes. How simple it is. See how simple. It's a overhang beam. It's a overhang. It's okay. It's a overhang. We took it. Just simply we take it and distribute it. Nothing. Okay. Simple. It's a fixed. We solve it. Okay. Simple. Now we will see another problems. It's a 50. There is no loading. Only a concentrated moment is there. It's a 50 kilonewton meter. 50 kilonewton meters. It's a 4 meters. It's a 2 meters. Okay. So we can assign numbers or names A, B, C. So, okay. See it is. There is no fixed end moments because there is no loading at all. We have a 50 kilonewton meter, a giant concentrated moment, a giant, not it's in between the supports. If it in between supports, we already know how the fixed end moments are there. M by 4 if it is exactly center. If it is not center, we have a formula, so no need to remember because so no, it's a luggage, no need to remember. Okay, that's it. If you see, there is no fixed end moments. MAB, MBA, MBC, MCB all are equal to 0. Okay, so carryover factor. See, not a carryover factor. See, distribution factors among is joint B. Only joint is there. What is a B? So PA stiffness is what? 4EI by L. Because A is a fixed end. A is a fixed end. That's why BA has stiffness of 4EI by L. But BC has 3A by L. So BC has 3A by L. Okay. C has a hinge end. We already discussed why it is a So if you see if it is a far end, you have to maintain a rotation. You have to maintain a rotation. It's like theta. We required how much moment is required? 4EL by x multiplied with theta is equal to m. So ml by 4EI moment is required to get a theta of 1 unit. Okay, 1 unit you require this much amount. If it is a hinge, if it is a hinge, if it is a hinge, how much moment is required? Theta. So ml by 3a. We already know theta is 3a by l. So once again, again and again and again, I will say these things are important. So that is the stiffness of the members. Stiffness means, what is the stiffness? That amount of force, stiffness you can call it as, it is equal to force when unit rotation or unit displacement is generated. The amount of force required, to generate unit deflection, or the amount of moment is required to generate unit rotation is called stiffness. That's it, now. That's it. Very small. Okay, that's it. See, now how can we distribute the moment? So if you see distribution factors for BA is what is 4 plus 3 7 4 by 7. So total stiffness is, you can call it as the stiffness of BA, you can call it as stiffness of BC. These are okay. So distribution factor is KBA divided by KBA plus KBC, total stiffness. That is a distribution factor. So this is a 4 by 7, this is a 3 by 7. That's it. Later 1 by 2 you are doing more calculations, so you can directly write out what is the distribution factor. That's it. So now we'll see how the problem is doing. Very simple. Very simple. It's a B, it's a A. You can write as a fixed. No need to mention the supports, but for visualizing, B has a stiffness. It is a 3 by 7. It's a 4 by 7. These are the distribution factors. Okay, distribution factors. Okay, let's see. This is a fixed end. A is a fixed end. See, see. Now you can see. So total amount of force is what? 50. What is the total amount of moment is? Total amount of moment is there. Total amount of moment at B is 50. Is it 50 na? So you can write it. So see. It's a first. It is a 0 fixed end moments. It's a 0. It's a 0. It's a 0. All are zeros. But one thing you have to maintain. So when the concentrated moment is acting, see, at the joint B, now you see 0 0. But in reality, a 50 concentrated moment is there. 50 concentrated moment is there. Is there na? So if you want, we already said it's previously said it. What we said previously? Yep. BA. So not a capital. Previously we solved the problems in slope deflection method when, so otherwise if you I want to show it, so I will show it. When the concentrated moment is acting, we solve the problems. Where it is? I think frames. Where it is? Concentrated moment is 40 kilonewtons. Na? What we discussed, giant equilibrium equation, where it is? Giant equilibrium equation? See, MCB, MCF, MCD is equal to minus 40. This is a giant equilibrium equation. Same thing now you can see, same thing. Final giant equilibrium equation is what? MBA plus MBC should be is equal to this is a clockwise now, should be is equal to 50. At the final it should be equal to 50 because at the giant has 50 is the moment is there. 50. MBA plus MBC should be equal to 50. Before, if it is something like there is no moment at this joint, so that's why MBA plus MBC should be equal to 0, because there is a joint equilibrium. Joint is also should be in equilibrium. MBA, MBC, so both are equal, but one is clockwise, one is anti-clockwise. One is positive, one is negative. So, but in this problem, B has a concentrated moment, 50. So, MBA plus MBC should be 50. Should be 50, na? So, that's it. So, how can we shift? How can we distribute that 50? It is a 50, na? It's a 50. How it is distributed? If you applied a 50, how it is distributed? We applied a 50. So, we applied a joint 50 at the joint B. How it is distributed to BA and how it is distributed to BC? Based on the stiffness factors again. So what is the stiffness factors? 4 by 7, 3 by 7. So we have to apply a 50 here center. How it is distributed? So 50 divided by 4 by 7, what is that value? What is that value? So one thing you have to remember, it has a length of 2 here. Okay, it's a length of 2. So there is no equilibrium. So a small mistake. So okay, distribution factors are not 3 by 7. So this what? 4 by L. So see, 4 by 4 EA, that is EA. Stiffness, it has 3 by 2 EA. So length is 2. Length is 2. So total stiffness is what? 1 plus 3 by 2. It's a 2 plus 5 by 2 is the 5 by 2 EA is the stiffness. 5 by 2 EA is the stiffness. So what is the distribution factor for BA? 1 divided by 5 by 2. That's it now. 1 divided by, it's a 5 by 2. That means 2 by 5. 2 by 5. So remaining is 3 by 5. Those are the distribution factors. Okay. So we have to take and consider L. So previously I didn't see it. So I feel that both has same length. Okay. So it has a 2 by 5. It has a 3 by 5. No need to calculate again BC. So both compulsory should be equal to 1. We have to distribute between among this. So okay, it's a 2 by 5, it's a 3 by 5. Okay, sorry, it's a 2 by 5, it's a 3 by 5. So very small length. See, if the length is small, the stiffness is higher. Stiffness is higher. One thing you can read. Okay, so how can you sir? So మనం చిన్నప్పుడు కథలు చదువుతాం చూసారా, పెద్ద కట్టిని విరవడానికి సరిపోద్ది. పెద్ద స్లెండర్ కాలం తీసుకున్నారు అనుకో, స్లెండర్ తీసుకున్నా అంటే ఈజీగా బెండ్ చేయొచ్చు, ఆర్ ఈజీగా బ్రేక్ చేయొచ్చు. అదే చిన్న కట్టి తీసుకున్నారు అనుకోండి, ఎక్కువ ఫోర్స్ అవసరం అవుద్దా. సో దట్స్ థింగ్. లెంత్ ఈజ్ ఇంక్రీజింగ్, స్టిఫ్నెస్ ఈజ్ రిడ్యూసింగ్ వెన్ కంపేర్డ్ టు rotational contribution or rotational stiffness. That's it. You have to, those are the normal visualizing. You can visualize how can it is reduced based on the length. Okay, so see, they applied 50 at joint. How it is 50 distributed? 50 distribution based on the stiffness factors. 50 divided by 2 by 5, it is what? It's a 20. If it is 20, it is 30. Same plus. That's it, no? That's it. So, but if you see it's a 20, the far end is fixed. We have a carryover factor. If you applied a 20 at this BA, so compulsory, we already know. Once again I will say it. If you applied a M here, we already calculated. M by moment is forwarding to the joint. If it is a fixed, if it is hinge, no chance. If it is hinge, both are hinges. If you applied a moment M, it is a hinge joint. There is no moment There is no moment at this joint. So this is called carryover factor. If it is fixed, carryover factor is off, and also in the same direction. Okay, so this, it is a 20, automatically transfer to the plus 10. It is a 30, automatically transfer to 0 because it's a hinge joint. That's enough. We distributed the moment. We distributed the moment between those joints. Between the joints. Okay. So that's the thing. So now we can see it's a 10, it's a 20, it's a 30, it's a 0. One thing you can observe it. In every problem, we taken this one or both are equal. We taken at the joint we have a same one moment. But now you can see two different. But if you add those, you can get the 50. It is a concentrated moment is there. The concentrated moment is 50. So it should be like this. So how can you draw bending moment? So that's it. No need. One just small. You can distribute the moment among the joints. That's enough. No need calculations. If you write down the bending moment diagram, see bending moment diagram. C has a 0. This is A. You can call it B. This is C. C has a 0. So now also it's a plus 30. Plus 30. Plus 30 means what? Plus means in a clockwise direction. It's a clockwise direction. So, okay. So clockwise. So clockwise is side. You can write is it's a 30. So again if you see it's a plus 20 again. So if it is A, this is B, this is B, this is C. This is again clockwise. Again clockwise. So again clockwise, you have to reckon this is 20. 20. This has 10. 10 has positive again. It's a positive. You can write it like. If you see now, observe it. B has a moment of 50 is there. B has a moment of 50. You can just add it. 20, 30. Concentrated moment. We already know if you draw shear force diagram. If you already know if it is a draw something shear force. If it is uniformly distributed load. If you applied a P or 50. So how it is shear force diagram? So it's a 20. It's a 25. It's a 25. If you observe it. Exactly at that location concentrated force is there. It is equal to 50. That's why we get 25 shear. But if we add just exact that location, we get 50 of shear force. The same thing is here also. You can get like this bend moment diagram. You can reverse it in the direction also. No need to write down bottom and below. Below and top, that is your choice. That's it, na? That's it. One thing, one problem. Very, very simple problem. So no need to do much more things when a concentrated moment is there. When concentrated moment is applied. Okay. So now we will go to solve another problem. Another problems. One by one. Another problems. We will solve so many problems. Okay, we will solve it. So now we will see now we will see a good problem. A hinge, a continuous beam. So okay, it's a 40. It's a 20 kilonewton per meter. Okay, so it's a 3 meters. It's a 4 meters. It's a 5 meters. Distance is 2 meters. Okay, this distance is 3 meters. Okay, and also you can take it as this is I, this is 2I. You need to careful when to find out the distribution factors. Okay, so now we can see the problem. So first we have to assign A, B, C, D. Okay, you can assign it. So first find out the fixed end moments. Fixed end moments. If it is fixed, if the supports are fixed, everything is fixed. There is no allowed. There is no rotation is allowed. That's are the fixed end moments. In reality, there's allowed rotations at B and C and D and A also. Those are adjoints. They have rotations. So how it is, if it is a rotation is allowed, how much moment is altered? There is a distribution factor. In slope deflection method, we calculated the rotations. Based on the rotations, we calculated the moments. In this, no need to find out the rotations. Just based on the distribution factors and the carryover factors, we can directly distribute among those. That's the simple logic between slope deflection and moment distribution. Moment distribution is very easy. Just so find out the distribution factors. See first fixed end moments. MABV, no need to write again and again. WL square by 12, it's a 15. MBA, it's a positive 15. Okay. So now MBC, so exactly it's a 2 meters. It's a 2 meters. PL by 8, 40, 44 by 8, 2 to 20. It's a minus 20. CB plus 20. That's it. So now MCD, we can observe it. So it's a 2, it's a 3. So 43 into 2 square divided by 5 square L square. So what is the value? It's a minus 0.2. MDC 42 3 square by 5 square. It's what? It's a 28.8. These are the fixed end moments. Okay, fixed end moments. So now we have to find out the distribution factors. Joints are there. How many joints are there? Joint B is there and joint C also there. Because joint B, two members are joint. Joint at C, two members are joint. CB and CD are joints. That's why we require two joint equilibrium equations at the slope deflection equations. Two joint equilibrium equations. Now we get distribution factors among at the joints. So find out the distribution factor. Joint C. So stiffness at BA. Stiffness of BA is, so A is a hinge joint. A is a hinge joint. So what is that value? 4EI by, so no need to write EI because everything is okay. In this EI is changing now. So we have to write it. So 4I by L is 3. So BC is, so again as I, it's C is, you assume it is a hinge joint. No chance at all. It's a intermediate hinge. It is a intermediate support. Intermediate support behave as a rigid joint. Intermediate support behave as a rigid joint. One thing you have to ask, you have to maintain. Okay. So once again I will write this. Intermediate hinge joint. Intermediate, there is no fixity. Intermediate, everything, every intermediate joint has allowed rotation. So no need to write a hinge. Intermediate joint behaves like rigid joint. I so many times from first class to last class, from the first class of structural analysis, I said, I think first class, I said, so what is a joint? What is a joint? It is a first class? No. It's a first class? It's not a first class. I think it's a first class. You can write it. So what is joint? Rigid joint. Rigid joint, pin joint, first class of structural analysis. I explained. So I explained the first class, what is a joint, what is joint, what is joint. Pin joint, rigid joint, pin joint. What is the meaning of structural analysis first unit, first class? Okay. Every time I explaining this bold. So see, it is a behave as a fixed support or fixed joint. So that's also 4EI by L is 4 meters. So now you can write 4 by 3, 4 by 4, it is 1. So total stiffness is 1 plus 4 by 3 is the 7 by 4. 7 by 3. No need to write EA. So distribution factor for BA. So 4 by 3 divided by 7 by 3, it's a 4 by 7. It's okay. It's a 4 by 7. So one thing you have to maintain. Sorry. BA is what? A is what? A is a hinge support. A is a hinge support. You may confuse. A is a hinge support. A is a hinge support. A has 3A by L. Okay. A is a 3A by L. A is a hinge support. Hinge support. It's a edge. So it has 3A by L. Okay. So now you can observe. Okay. It's a 3A by L. It is a EA. So BC is also fixed. Far end is fixed. C behaves as a rigid joint. C is fixed. So we can take it as a 4A by L. So 4A by L is 4. So it's also 1. It's also 1. So total is 2. So total 2. Distribution factor is 1 by 2. So distribution factor for BC is again 1 by 2. Half it's distributed among those. Okay. So now we will go to joint C. CB taken. CB. B is behave intermediate joint. It's a intermediate supporter. So it's behave as a rigid joint. So 4EI by L. 4EI by L is 4 meters. So you can call it as 1. So next CD. Now observe it. D is a hinge joint. D is a hinge joint. Are understood? So it's a 3A by L. 3EI by L, but you can observe it. It's a 2I. The cross section is different. If the cross section is increasing, I is increasing, stiffness is increasing. I is increasing, stiffness is increasing. So 3 of 2EI divided by length is what? Length is 5 meters. Okay. So this is 6 by 5. Okay. So total stiffness is, so 5 is 11 by 5. Okay. 11 by 5. That's it now. So 11 by 5. So now distribution factor for CB 1 divided 5 by 11 na? 5 by 11. So what is that 5 by 11? So 1 okay. So see this, what is that value? 5 by 11. Some of the textbooks may be wrong. Okay. So 5 divided by 11. Sorry. 5 divided by 11. 5 divided by 11. It's a 0.45. Okay. Now distribution factor for CD 6 by 11. 6 divided by 11. So what is that value? 0.54. So total must be equal to 1. Okay. Distribution factor means we distributed among those two joints. So everything total will completely equal to 0. Equal to 1, not 0. Okay. That's it now. That's it. Maybe some of the textbooks may give false data or some may be in errors. No need to consider in a textbook some false data. In this textbook it gives false. Okay. They didn't see the 2EA. Okay. We will consider 2EA. That's it now. That's it. Now we will do problem. Very simple. Very simple. So take it as A. Take it as a B. Take it as a C. You can write as a D. Distribution factors are there at B and C. So BA is 1 by 2. You can write 1 by 2 and 1 by 2. It says 0.45, 0.54. That's it now, CB. So we can put a closed. That's it. That's it. So now we will see. we will write the fixed end moments. Fixed end moments A and B, C, D. So what is that moments? 15 and 15. So it's minus 15. It's a plus 15. So you can maintain that. So BC 20, 20. It's a minus 20. It's a plus 20. That's it. Maintain. CD, DC minus 19.2. So DC. So plus 28.8. Okay. 28.8. That's it. Na? That's it. Now we can distribute it. How can you distribute? Very simple, easy way to understand. See, just observe it. Just observe it. You can easily distribute it. You can easily distribute it. First you have to consider. First one thing you can consider. A is a C. Once C, A is a hinge joint. The final end moment at the end of A should be 0 because it's a hinge. D is also hinge. So finally it gets to 0. Compulsory it should be 0 because it's a hinge. So first we will consider those things. So it should be equal to 15. It should be equal to 0 at the end. A should be equal to 0. That means what? We have to apply a 15. So now it's going to be 0. Okay, that's one thing. So one thing you have to observe it. If you applied a plus 15 at this joint or at this support, if you applied a plus 15 clockwise direction 15, it's going to be 0 at support A. Okay, no problem. But see, if you applied a 15 at here, the far end is a B. B is there in the far end. Far end is a behaves as a fixed end. It's intermediate end. It receives half moment. I already said it's a carryover factor. So it's a carryover factor. I also said if it is applied a 15, so it receives 15 by 2. Carryover factor, na? Carryover factor is off. So now if you applied a 15, it receives 15 by 2. What is that value? 7.5 in the same direction. In the same direction. That's it, na? So we already derived different situations. What is the carryover factors? So that's one thing. Again, it's 28.8. So we have to maintain 0 at D. So you can apply a plus minus 28.8. So again, C is a fixed end. So intermediate hinge behaves as a fixed. So half will goes to the joint. Near end. So near end means this. You have to maintain this. Okay. So half, what is that half? 14.4. Okay. Minus 14.4 because same direction. That's it. A and B we can leave it. A and D we can leave it. Their distribution we distributed or we carried or we maintained A and D 0. That's enough. One thing is over. Now we can observe it. Now we can observe. One thing you can observe. One thing you can observe. This is the story. Now you can observe a joint B. It's a B. You can write it's a B, C here. So now observe. At the joint B, joint equilibrium. At the joint C, equilibrium of C, MBA, MBC should be equal to 0 because there is no concentrated moment at GB and C also. We have to maintain like this. That means MBA equal to minus MBC. Both are equal and compulsory opposite to the sign. Then only it's a maintain joint equilibrium at joint B and C also. Now you can find out what now you can find out what is the BA and what is BC. So BA is what? 22.5. Yes, no? It's what? It's a 20. Now you can see C it is a 20. It's what? Oh my god, it's something 19.2 plus 14.4. What is that value? 33.6. These are not equal. We have to maintain that. That's it now. We have to maintain that part. We have to maintain. So if you see how much is error at joint B? Error at joint B is a plus 2.25. 2.25 is higher. If you just add both, what will get? 2.5. 2.5 positive is there. So what we will do? We have to apply minus 2.5 at the joint B. At the joint B, you have to apply plus 2.5. That's it, na? So now I will write another line. You have to apply minus 2.5 at the joint. That's it. That's the solution. In the same C, you have to apply how much it is? Minus, it's if you add it, minus 13.6. You have to apply plus 13.6. That's it. Huh? You have to apply plus 13.6. Then only the giant equilibrium is stable. So now start it. Now start with giant B. Giant B. Applied minus 2.5 at giant B. So how it is distributed among BA and how it is distributed among BC? That is the question. How it is distributed among BA and BC? So you have to apply minus 2.5. It is distributed based on the distribution factors. So the distribution factor is off. So they will take off and off. So what is the off? It's exactly off is, if you applied minus 2.5, it's take 1.25. It's take 1.25. It's take 1.25. హలో క్లాస్ చెప్తున్నాను ఒక 20 minutes. Is it okay? Okay, no problem. Visualizing. Okay. See, same thing. Now you can observe. Now observe. Same. We have to apply plus 13.6. Plus 13.6 at the joint C. How it is distributed among BC, CB and CD? Same thing based on the distribution factors. How can it see? 13.6. In 13.6, 0.45 percentage goes to the CB and 0.54 percentage goes to the CD. So now, what is the distribution factors? You can write. So there is no place you can do an outside. So I will write below. So plus 13.6. You have to goes to 0.45. One thing, plus 13.6, 0.54 goes to another. So what is that value? You can directly write it. So 13.6 multiply with 0.45. So it's a 6 point. So okay, 6.12. 6.12. Okay, 6.12. This value. So remaining value, you don't need to find multiply with 0.54 because 13.6, 6.12 goes to this, and remaining what is that value? Otherwise you can multiply with 7.34. 7. So 13 point exactly 7.34. Okay, it's a 7.34. That's it. So now if you just remember, so A is a, if you applied a 1.25 here, A is a hinge and there is no carryover factor. If you apply 7.34 here, D is a hinge and there is no carryover factor. There is no carryover moment. So that's it. Okay. But now if you just calculate 22.5 minus 1.25, what is that value? 22.5 minus 1.25, just see it. Is a 21.25. 21.25. See other side also 21.25, 21.25. That's it. Okay, over. Now you see 26.12. You will get 26.12 minus 33.6 plus 7.34. What will you get? You will get same 26.12. That's it. It's over. But it's not over. Sir, what is the problem? What is the problem? So problem is arise. It's a continuous beam. It is a continuous beam. Problem arise where it is. Where? See. You just applied 1.25 here. You applied 1.25 here, na? But you see, if you applied 1.25 here, this far end is, that far end is C. C is a fixed rigid joint, na? So behave as a fixed. So the carryover moment is forward. Carryover moment is forward like this. Okay? Because C is a fixed, behave as a fixed. It's a rigid joint. So 1.25 applied at a BC at the B end. So C end it carries half of the moment. So what is half? What is half? 1.25 divided by 2 is 0.625. It carries minus. And also same thing. Here you applied 6.12. The carryover moment will forward to the P end. Carryover moment is carried to B end. So what is that moment? 6.12 divided by 2 is a 3.06 plus. Now again the problem will come. Now if you see BA and BC is not equal to maintain 0. So previously it's exactly 21.25, 21.2 is okay. But now if you see the BCN, it's a 21.5 minus 3.06. It's 18.4 for now. So again we have to distribute this 3.06 between B and BC. Then only we will maintain the giant equilibrium of B. Okay. Previously it's over. Now if you observe it, previously in this up to this it's over. We feel it is over, but we forget the carryover moments. So we take the in consideration of the carryover moment. So this much is extra. It's an imbalance, na? It's an imbalanced at B. This much is imbalanced at C. So we'll again the distributed 3.062 between B and BC exactly maintain the equilibrium of giant B. So that is even our procedure. So again, if you see, how can you distribute it? How can you distribute it 3.06? 3.06 is distributed. So 3.06 between same distribution factor of 3.06 divided by 2. What is that value? It's a 1.35, 1.53. It's a 1.53 minus because it's extra of plus 3.06. 3.06 is extra at giant B. So we have to apply minus 3.06 at the giant. So now it's distributed minus 1.3, 1.53. So see 0.36 minus of minus 1.53, you will get minus 1.1 plus 1.53. It's also minus 1.53 distributed. It's distributed among B. Same thing. Minus 0.625 minus 0.625 multiply with 0.45. It will come 0.28. So it's a negative. It's a negative. It's unbalanced. We have to balance it. We have to maintain. So we applied a positive 0.28. So this much is remaining 0.625 multiplied with 0.54. It's a 0.33. Again over? No. Again not over because again the carryover moment is forward off. 1.53 divided by 2. So it's a 0.76 will come. So again this minus. Again 0.28, 0.14 will come. So again this is unbalanced. 0.14 is unbalanced. This is 0.78, 0.76 is unbalanced at the giant. So we have to distribute it between same thing. So 0.14. So we have to distribute it among B and BC. How it is? 0.07. So 0.07 minus. There's a positive extra is there. We have to maintain minus and minus. That's it. Now it's 0.76. 0.76 multiplied with 0.54. So 0.41 here. 0.76 multiplied with 0.45. 4 here. Sir, how many times? It's not ending. It's not ending. It's going on 0.00 something. So we can end at somewhere. Okay. Okay. Because if you see 0.07 is very small. Take over the carryover factor. Again we will get a carryover movement. But these are very small. So you can reduce or you can stop it there. No need to distribute 0.00, 0.035 will come now 0.035. So again the 0.35 we can distribute between two very small changes. No need required. So we can stop at 3 iterations. We can stop it. 3 iterations we can stop it. Otherwise, if you feel those are the minimal moments, you can stop it. So no need to write this. So now you can just submit. Just submit. So just submit. So how it is, sir? What are the sum? What are the sum? So no need to. So just see. You can just submit. So 22.5. So 1.25. What we applied. Okay. What we applied. So just submit. 22.5 minus 1.25 minus 1.53 minus 0.07. So what will get? It's a 19.67. See if it is other side also will get almost equal because we didn't take further iterations. Very minute error will come. Minute error. So we'll get minus 19.6. So otherwise check it is minus 20 minus 1.25 minus 1.25 plus 3.06 minus 1.53 plus 0.14 minus 0.07. You will get C exactly minus 19.65. You can submit everything. Okay. So you will come almost equal. What is the error? We curtail certain iterations. That's why very small minor error. So again see this end you can see no need to calculate both ends. If you have a brain, just do one side and remaining is also same. Okay. So I will calculate the one end. So previous end it's good minus 33.6. So otherwise no need to write it. No need to write this also. This phase also. This phase just sum it at that location. If you have a good iterations, no need to write this. Otherwise, if you submit 21.25, you can write it. This we just submit la 15.7.2. Otherwise, if you don't write this phase, you can sum all. That's enough. But for your understanding, I write it. I summed it at that location. Okay, I write at summed at that location. Otherwise you could just visualizing or just seeing and you can apply distribution moments. So no need that summed at that location. You can, that is easy because you can sum everything from top to bottom, but we already summed at certain location. We can carry out from that point. Okay, so that's it. See minus 33.6 plus 7.34 plus 0.33 plus 0.41. That's it. It's a minus 25.52. You will write it. It's also plus 25.52. Because at the final both are should be equal. If it is not equal also you write it like one thing. You fix at least one thing. It's also minus 19.67 because at final the both should be equal. So why it is not equal? Because we curtail certain iterations. So but you have to write both are equal. That's good. Because if you write both are equal, then only you understanding the problem because we maintain the giant equilibrium of B. Okay. So that's it. That's the whole. So now you can draw bending moment diagram. B, C, it's a 0. So what is BA? It's 19.67. You can write it. It's a 25.67, 25.52. So this is 19. Okay. It's a 19.67. It's a 25.52. Both are hanging moments only. You can just otherwise observe it. It's a 0. It's a clockwise. Again, it's anti-clockwise. Anti-clockwise. Both see, both are hanging moments. We discussed. We write so many diagrams. So this is 0. These are the fixed end moments. So and also you can write it. What are the? Those are the end moments. So those load moments also. It's a 20. So exactly will come it like it come. So point load is there. Maybe it is increasing or decreasing. I don't know. You can find out. It's also point load is there. Na? We have to find out what is that load. So okay, these are all collapse. Only this thing is come. This is positive, negative, 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 negative. This may be positive. Whether it is crossing that part, this is crossing part or inside a part, just calculate it. Just you can calculate it. Because just PL by 4. Center. Na? Center. What is that value? Okay. That's it. That is the bending moment diagram. Later you can draw shear force also. Shear force also. You can write shear force. That's it. It will come like this. Come like this. It's also na. So it's uniformly distributed na. It's uniformly distributed. It will come like this. This is a shear force diagram. You can find out the values. Very simple. You can write it because see these are point loads. These are the point loads na. These are the point loads. This is a uniformly distributed load. UDL will come like this. Point load will come like this. You already know it. So that's it. That's it. That's the end of the story. So different beams loadings you can take it and you can. This is important. This is important. How it is distributed among the parts. So okay, distribution factors and carryover moments. Distribution factor, carryover moment. Distribution factor, carryover moment. So okay, that's it. Tussle between them. Okay, so that's it. That's the enough story. So tomorrow we will see the frames. Okay, some frames. Giant. If a giant has a 3, so we will first see one frame which has giant of 2 beams. Next we will see a giant has 3 beams are joining. We will see it. Okay, that's it. If you have a doubts, ask me. Otherwise, leave it.